After the last video, you might be thinking, I'm never going outside again. Look at all that air pollution that's caused by smog and the particulate matter created by factories and stuff that's all blowing around outside. I'm going to stay inside where the air is healthy and clean and safe to breathe. But as it turns out, that is no refuge. In highly developed countries, we have a lot of those volatile organic compounds we discussed. Well, they're given off by carpets and carpet cleaners and furniture polishes and other materials that we keep inside of our houses. We also have a lot of oil heat or gas heat that's burning material. It's combustion reaction inside of our house, and sometimes you get leaks and that kind of thing. You have people breathing in and out inside the house, increasing carbon dioxide. So once those are generated, inside a house you have these obviously have walls, right? And so the air doesn't mix with the air outside nearly as readily. And there are 11 air pollutants in the United States that have higher concentrations inside than they do outside. This diagram on the upper right gives you a really good idea here. If you're to take all of the air in a standard size room, 20 feet by 20 feet by 9 feet tall, so it's like a living room, and you were to pool all of the carbon dioxide, all of the methane, all of the greenhouse gases that are inside that room, you would end up with about 3 gallons of greenhouse gases for a room that size. And they have that example right here, the person standing next to what would be about the equivalent amount of greenhouse gases, which is distributed throughout the room. It's dispersed, but that's how much there is in there. In less developed countries, they have a lot of particulates, suspended particulate matter, and other types of emissions that come from cooking fires. So burning wood or charcoal or dung in, and just regular hunks of coal in fires. Well, some of those are inside the houses, inside whatever structure they're living in. So you get collections of material, right, because the walls are preventing the air from mixing with the outside, and you get higher and higher levels of these pollutants inside. So is that a concern? It is if the pollutants get above what are called threshold levels. These are concentrations of pollutants below which we don't really observe any negative health effects. A lot of these things we consider pollutants are quantitative pollutants, right? You remember quantitative pollutants means it's a normal thing in the environment, but it's the amount, the quantity, that makes it dangerous. At the point where the amount goes above a threshold level, above a threshold concentration, then we start to notice observable, measurable health consequences as a result. This statistic at the very bottom floored me the first time I read it. If you are in traffic, right, let's say on the freeway, we're in like Los Angeles or Mexico City, one of these places that have lots and lots of smog, lots of pollutants, the air pollution inside the car can be 19 times higher than the air directly outside the car. Just opening your window, right? You would be letting air that's 19 times cleaner into your car. And that may be as a result of certain air conditioning systems that recirculate the air from the outside over and over and over again, so it's getting more and more concentrated. But that's a profound difference between indoor and outdoor air pollution. So when you say you're going outside for a breath of fresh air, it's usually true. Usually the air outside is a bit cleaner than the air that you have inside. Not only that, talking about suspended particulate matter, inside you get a lot of collections of dust, so you're breathing in that material as well, whereas outside you don't tend to have as much dust. I mean, you have some from like dirt and things like that if it's been really dry, but typically you don't have just dust aggregating and aggregating and aggregating in layers the way you do on interior material. Obviously, it's going to be a little bit different depending on how frequently you clean. So here is a cross-section of a house, and it notes the kinds of air pollutants that are common inside homes and what their sources are. So paradichlorobenzene is a kind of volatile organic compound that is found in air fresheners and mothballs. I don't know if any of you have ever even seen mothballs before, but this is a kind of, it almost looks like a little white ping pong ball, and it's a chemical material that is meant to have a smell that keeps moths away, and it's the smell that keeps people away as well. They're not a great smell, but the threat of breathing in these paradichlorobenzenes is that it increases the rates of cancer, lung cancer, and things like that. Chloroform. Chloroform you might be familiar with as a chemical. It's used as a plot device in a lot of movies, right? Someone pours a rag full of chloroform and they put it over someone's mouth and they lose consciousness, in a lot of spy movies and things like that. What turns out that in situations where you have a heavy amount of chlorine treatment in waters, and then you heat that water up to near boiling, that can actually catalyze a reaction where the chlorine combines with some of the water and you get chloroform coming out. And again, chloroform is a cancer-causing agent. Now, I don't mean to scare anyone. Taking hot showers is not going to noticeably increase your risk of cancer unless you have extremely chlorinated water. So this is not something that you need to be that concerned about. The relative threat increase is something that we can measure, but the overall risk from that one is not too high. So don't stress out about that. Aerosol sprays can have chemicals inside them that can cause dizziness, so things like spray deodorants and hairsprays and things like that. They've been changing the chemical compounds in a lot of aerosols, especially after CFCs were outlawed, so that is probably getting better. Some of these are from dry cleaning fumes. Some of them are from carpet fibers and plastic products. A lot of carpet is actually just plastic threads. Formaldehyde from furniture stuffing and paneling and particle board and foam insulation. And speaking of insulation, asbestos. I found that a lot of people know that asbestos is bad, but actually very few people seem to know what asbestos is. So asbestos is a fiber that is produced from a kind of rock, usually from serpentine rock, and we have a lot of serpentine in this area, so we have quarries that look for this kind of rock. And when that fiber is spun into insulation, it can sometimes break up into little particles, and you breathe in these little particles of these rock fibers, it can dramatically damage your lung, causing lung disease, lung cancer, these kind of things. And this is why we've cleared asbestos insulation out of a lot of our areas. Asbestos is still used for other products. One of the reasons why it was used for insulation in the first place is because it's extremely flame retardant. It's very hard to light asbestos on fire, so it kind of helps fireproof things. But because it was increasing rates of lung cancer and lung disease, we started clearing all of that insulation out. Fake fireplace logs are frequently made from asbestos, and there's really not much of a concern there because it's not been spun into these really, really tiny, fine fibers that would be causing that danger. But yeah, asbestos, especially in old houses, is something of a concern if there's asbestos insulation. We talked about carbon monoxide, and we talked about formaldehyde, and we talked about some of these other ones. Tobacco smoke, if someone's smoking inside the house, secondhand smoke is a big killer. One that's kind of a unique pollutant for inside houses is radon. Radon is a radioactive gas, and it's generated by the decay of other types of radioactive isotopes that are in rock layers around your house. And it can seep in through the concrete, through the foundation of your house, and be quite dangerous. So like most radioactive things, it can cause cancer. And before you go buy a house, one of the things you want to make sure that you do is get it tested for radon, because you do not want that gas collecting inside of your house. Outside, it's very rare that you have to worry about breathing in radon because the air's mixing, right? The wind is blowing, all that kind of thing. But inside houses, it can collect together in higher concentrations and get above threshold levels. So about 3.8 million people a year die prematurely from illness attributable to indoor air pollution. About 27% are from pneumonia, which is exacerbated from breathing in this air pollution, 18% from stroke, 27% from ischemic heart attack, heart disease, 20% from chronic obstructive pulmonary disease, and 8% from lung cancer. So indoor air pollution is also a huge concern in addition to outdoor air pollution. So this slide is about radon. We talked about all those outdoor air pollutants, but specifically one that's most dangerous inside is radon. And this is an info sheet taking information from the EPA and other organizations as well. Radon is a naturally occurring radioactive gas in some types of soil and rock, and it can seep into homes and buildings sitting above such deposits. Remember when we were talking about nuclear energy. Right? And we talked about atoms and how when the nucleus of an atom is unstable, like in uranium isotopes, that the protons and neutrons in that nucleus, well, they'll rupture, it'll break in half, and that releases a whole lot of energy. That's the radiation. Well, radon is some of those fragments of other types of radioactive elements that break off as it decays. So you have these elements that are in the rock layers below the house, and as they continue to break down, which radioactive materials do, the radon are these little particles of it, little pieces of it that come out and form their own kind of gas. Now, this infographic was made for Massachusetts in particular, so about a quarter of homes in that state have the potential to exceed the EPA's recommended radon levels, which is the threshold levels. And radon is responsible for about 20,000 lung cancer deaths per year, I believe specifically in Massachusetts there. So it is definitely a concern. So between the last video and this video, we've talked about a lot of sources of pollution, ways that pollution can actually become concentrated, ways that it can react and become worse. How do we reduce air pollution, though? How do we reduce the amount of outdoor air pollution? Well, one thing is reducing consumption, right? Every kilowatt of energy that you consume, right, for any electronic device, well, that had to be produced somehow. If it was produced in an energy facility that burns coal, you're creating a lot of air pollution. But even if your energy comes from wind and solar, you need to manufacture the materials for those windmills. You need to manufacture the material for those solar panels, so they don't have zero carbon footprint. There's still air pollution associated with the production of that kind of energy. So simply reducing the amount of energy that we use is one aspect. But that puts a lot of the emphasis on individual action. And it also, it's hard to take these kind of individual steps to reduce your own consumption if it's not guaranteed that everyone else is going to be doing their part as well. A better approach is to have large systems, usually enforced by government regulatory agencies, that manage the way that companies produce energy and society as a whole produces pollution. So one method to do that is just to put a hard limit for how much pollution can be produced by any given company. You say if you go over this amount, you have to pay huge fines, or there will be criminal penalties, something like that. And if you're under this amount, you're in the clear, and then every company is producing less waste. However, not every company, not every factory, not every energy plant is going to be producing equivalent amounts of pollution. So it's a little bit short-sighted to just apply a single amount of pollution per year that every factory is allowed to produce, because some industries are just going to necessitate producing more pollution than others, and some of them are very necessary to the economy or necessary to the functions of society. So you would need to come up with some sort of system where you classify different factories, different kinds of companies, different types of activity into all these different categories, and then say, well, in this category, you can create this much pollution, right? Another way to go about it, though, is to use what we refer to as a cap and trade system. Now, this has sometimes been politically unpopular, sometimes politically popular, and it's been advocated for and argued against by both sides of the political aisles. So how does this work? You set a limit for how much pollution every kind of company can create. Now, if a company produces less pollution than they are allowed to, what you allow is for them to take that remainder, the difference between how much they were allowed to pollute and how much they actually polluted. You take that difference, and they're allowed to sell that to another company. So another company could purchase with money more ability to pollute, the right to do more polluting, right? They can extend their own limit, but they have to pay for it. And they pay for it by giving money to different companies. In addition, this incentivizes those companies that are able to produce less pollution, because they can actually get some money from their leftover pollution credit. So this simultaneously encourages companies to produce less pollution, to take steps on their own to become more efficient, to become cleaner, to become greener, while allowing a little bit of wiggle room for those companies that they can't make these kind of adaptations or it just wouldn't be profitable for them. They have to pay out of pocket to be able to exceed that pollution limitation. Now, one of the reasons why this is maybe better than just applying a fine to companies is that sometimes fines are very difficult to actually enforce, and different regulatory agencies under different administrations may or may not take that fining system seriously. They might not enforce it or go after that money as well, and companies can tie things up in legal avenues for years and years and years and never actually end up paying it. But if they have to purchase that credit from another company, then it's a very simple transaction, right? They're still paying out of pocket for it, so it costs them money, but they don't get that credit otherwise. The other thing is that if you have a fine, it kind of is set at a certain amount, and inflation or the ups and downs of the economy could mean that that amount is way too burdensome or way too low. So you allow market forces to determine how much a pollution credit would be worth, which makes it continuously an attractive option for selling your excess credits. Now, I say all that, you still have to enforce this with fines. If a company doesn't buy the excess pollution credits and they still continue to pollute, you would still need some sort of fine or legal action required. So it's not totally independent of that system, but it allows a kind of capitalist approach to reducing pollution. And if you're in the United States, telling someone that it's a free market solution is that's an appeal, right? People like to hear that. So here we have some statistics, just enforcement of the environmental regulations that we have on the book, strict law enforcement, imposing fines, that sort of thing. Between 1980 and 2012, lowered the emissions for 6 major air pollutants by 67%. But then, if you look at specific types of pollutants, depending on how low the initial cap is set and how often this level is going to be lowered to improve control, because we always want to be reducing our emissions year by year if we can. Between 1990 and 2012, so 20-year period of time, 22-year period of time, emissions trading, this cap and trade system, reduced the amount of sulfur dioxide emissions from power plants by 76%. That is profound. So some people don't like this kind of cap and trade system because it allows companies to purchase the ability to pollute more, and that doesn't seem right. But you can argue with results, and that is a pretty profound result. So even if you don't like it in concept, if it works, it's worth giving a shot. So what kind of regulations do we have? Well, one of them that you definitely need to know about is the Clean Air Act, signed in 1970, so before the Clean Water Act, but still in the 70s. The EPA is required to regulate pollutants that endanger public health and welfare, and we've seen that lots and lots of both primary and secondary air pollutants meet that criteria. They endanger the public welfare. State and local governments also monitor and enforce the Clean Air Act regulations. So you have the EPA, which is working in coordination with state and local agencies to do this kind of scientific monitoring. And if we notice one pollutant getting way out of hand, its levels are going up, that indicates that maybe something's going on, and we can come in here with some more enforcement. It's estimated, the Clean Air Act is estimated to have prevented over 400,000 premature deaths and hundreds of millions of cases of respiratory and cardiovascular disease. Now, I can quote statistics at you till I'm blue in the face, but at the end of the day, stories tend to work a little bit better. So I'm going to tell you a story about a guy by the name of Thomas Midgley. Thomas Midgley was a chemist. He was a scientist, and he is as near a supervillain in terms of environmental history as we are likely to get. So he is the scientist, the chemist, that invented tetraethyl lead, which was the lead additive to gasoline. If you know about engines or anything like that, there's a kind of inefficiency that can pop up in engines which causes a noise, which we call engine knock. So what he found was adding tetraethyl lead into the gasoline reduced engine knock, it's exactly what it sounds like. It's this kind of clicking sound that engines kind of make. The problem is that lead is a neurotoxin. It is a deadly poison which causes developmental disabilities, especially if kids have it in their system. And as we were burning so much gasoline from all of our cars, all of our engines, we were pumping more and more and more lead into the atmosphere. Lead was also used as an additive in all kinds of things. It was used in paints and stuff like that as well. So for a while, we were saturated with this neurotoxin, with lead all over the place. He is also the guy who invented Freon, which is a CFC that is principally responsible for the depletion of the ozone layer. So Freon is used in air conditioners, it's used in refrigerators, and he invented this kind of class of molecules, the CFCs, which are used in aerosols and spray deodorant and all these kind of things. And those started eating away at the ozone layer. So the amount of lead in people's bloodstreams increasing, and the destruction of the ozone layer, both of them coming from this one guy's invention. Now, you could say he didn't know that his inventions would have this kind of far-reaching consequence, but he, after the data was out, after the scientific information was out that demonstrated the problems with these chemicals, he went through a campaign, a media campaign, to downplay the results, to offer research that was very, very questionable, that called into question these things. He actively encouraged people to use these destructive materials after he knew how much damage they were actually doing. So that's Thomas Midgley. Enter the Clean Air Act. The Clean Air Act cuts ground-level ozone by 25% since 1980, reduces mercury emissions by 45% since 1990. We talked about how nasty mercury can be. It reduced SO2 and NO2, sulfur dioxide and nitrogen dioxide, by 71% and 46% respectively. So the Clean Air Act does a lot to reduce acid rain. It phased out those chemicals that degrade the ozone layer, the CFCs like Freon, and then here's the big one. It reduced the lead content in gasoline, which has subsequently led to the air pollution from lead being reduced by 92% since 1980. And you can measure this. The amount of lead inside people's bloodstreams in 1970 versus the amount of lead in their bloodstreams now is dramatically lower. And you can do that test by grabbing baby teeth. Creepily enough, baby teeth contain trace amounts of the amount of lead that was in the atmosphere. So it's in your system when you breathe it in. And then by comparing the chemical composition of the baby teeth 20 years ago, 30 years ago to the ones today, we can see that the amount of lead in our bloodstreams, the amount of lead in the atmosphere, everything has gone down. So that is a profound victory for the Clean Air Act, and ensuring that more babies are going to grow up without those developmental disabilities caused by breathing in this neurotoxin. So here is a graph to show you how that worked. 1970s, the Clean Air Act goes into effect. We realize that the amount of lead in gasoline is causing the average amount of lead in our blood to increase, which is very, very dangerous. So you can see that as we lower the amount of lead in gasoline, shortly thereafter, the amount of lead in people's bloodstream starts going as well. So the two are paired together till it falls to an extremely low point in the 1980s, and it has continued to go down since then. Now, like most of you have lived your entire lives in a world that did not have large amounts of lead in the atmosphere, but there used to be a lot of it. So environmental regulations work. So we have the Clean Air Act, which under the provisions of the Clean Air Act, we were able to ban leaded gasoline, which helped a lot. Using cap and trade systems, we've been able to reduce the amount of nitrogen dioxide and sulfur dioxide in the atmosphere, reducing the amount of acid rain, which is why you don't hear nearly as much about acid rain as you did 20 years ago. But carbon dioxide, and methane, which are both organic compounds, is the principal thing responsible for another air pollution effect, which is global climate change, the increase in the average global temperature and the shifting of precipitation belts and that kind of thing. We do not have, in the United States, we don't have a cap and trade system for carbon, nor do we have what's called a carbon tax, which would be a flat price, a flat tax applied to all materials which create an excessive amount of CO2 or methane and dump it into the atmosphere. And because a lot of the industries that are principally responsible for the amount of CO2 increasing in the atmosphere are so profitable, they've been able to lobby with extreme pressure, and I'm talking specifically about the fossil fuel industry, to prevent any kind of climate controlling legislation or carbon controlling legislation from going through these very, very massive and unfortunately successful misinformation campaigns, which are meant to question the validity of climate science. So the next thing we're going to talk about is climate change.